Thanks everyone for joining us. All right, let's make a start. Welcome everybody to GLA Summit 2020. Super excited to be part of this, this global LabVIEW event. My name's Chris Farmer, and co-presenting with me today is Stuart Trevillian. We both work at Wired in Software. We're an alliance partner in Melbourne, Australia. Alliance partner with National Instruments, that is. Our presentation today is integrating non-NI tech with LabVIEW NXG Web Development. So yeah, we can't wait to share some of our experiences. So starting with our giants are female. This is a great initiative by Fab to talk about the achievements of great female pioneers in engineering and computer science. Today I've picked Mary Emma Greer. Mary Emma Greer was the first woman employed at Adelaide Observatory, in 1890 here in Australia. She was part of a group of underrated women who became known as the computers. They were so named because their role was highly mathematical and analytical. They had to perform a lot of astrographic calculations. She got quite involved in taking a lot of images from the telescopes and doing a lot of calculations about determining where all the stars were. So basically cataloging the stars. It was pretty grueling work, complex work, needed precision and consistency. They also had to be really well educated to do this. They needed a good grasp of maths, especially geometry and applying logarithms. In Australia alone, there were 72 women across 4 different observatories, and they managed to catalogue 18% of the entire sky, over 1 million stars. Quite an achievement. So really set the foundations for women working in complex technical roles such as this. And yeah, they were called the computers. That was their nickname. A fascinating story. I want to give a shout out to the team, the GLA Summit team. Thank you so much for putting this together. Thanks for having us, allow us to present. Thanks to Chris, Tom, Fab, Sarah, and Peter, and also the sponsors, Hilla, VIPM.io, and NI. Really appreciate that this is going ahead, and we're honoured to be part of this great initiative. Very much appreciated. All right, a brief introduction to Stuart and I. We both work for Wired in Software. Stuart Trevillian, he is our senior software developer at Wired in Software, and he's a certified LabVIEW developer since 2008. His catch cry is turning coffee into LabVIEW. He's been doing it for more than 20 years. My name's Chris Farmer, and I'm the founder and the LabVIEW architect at Wired in Software, and been certified LabVIEW architect since 2008. I am the host of the recent LabVIEW podcast. It's called the DQMH Podcast. Please check it out. Okay, so what are we here for? Today, we're here to share with you our recent and first experience at a LabVIEW NXG web app project. This is based on a real project that we just finished only a couple of months back. The whole way through the development of this project, we found ourselves in the deep end. We sort of had to learn to swim again. The content out there in the community on building a complex NXG web app, it's still fairly light on. There's plenty of good basic information out there, but yeah, it was a bit light on in terms of the deep technical stuff. So we're going to share a few of our war stories here today. Hopefully you can gain from that experience. One of our challenges was learning the non-NI tech. So this was not our typical wide-in LabVIEW application that we do day in, day out. We had to learn about concepts like web app communications, web services, web cameras, web browser tools, IT concepts such as digital security certificates and firewalls and permissions. To do this, what we're going to do, we're going to walk through our solution design, how we tackled this problem. We're going to give you a bit of an overview of the background of the project, provide you a bit of context. And then what we're going to do, we're going to get Stuart to dive into some of these challenges that we faced and discuss a handful of the tips that he's curated to get you on the right path. And he'll throw in a few demos to see how that all comes together in NXG. So it's fair to say we had to lean on these guys a bit. So this is our journey of how we had to leave our comfortable labverse and jump over to the dark side of IT. So when we say non-NI tech, what am I talking about here? We're talking about web application communications. So by utilizing HTTP communications with things like publicly available web services, but we can also create those services ourselves. We're talking about web services. A web service is an interface that we can use to transfer data, such as XML or JSON formats, and an interface to a database server. It's a tool that allows us to provide a separation, a security layer perhaps, between our applications. We're also going to, we're talking about databases. In this instance, we use SQLite. There's a bunch of associated tools that we use to view the database, such as Heidi SQL and SQLite Studio. We're talking about webcams, integrating webcams. Well, getting too ahead of myself there. We're talking about integrating webcams into an NXG application. So how we went about that. So third-party webcams already installed in our customer's factory. We had to work out how to integrate these. I'll admit, when I first heard that that's what they wanted us to do, I sort of thought, oh, that's going to be pretty ambitious. But to Stuart's credit, he was able to work out a fairly simple way in the end how to do it. It took a while to get there, but we got it. Placeholder HTML containers, which is a new feature of NXG, an NXG web feature, allowing you to bring dynamic HTML into your application. It uses the Reflect JavaScript, so we'll learn a bit about that. Browser web tools. So we got to get familiar with how you use, the web tools in your browser. It was very useful. Non-NI, so other non-NI tech, is a lot of the IT stuff, IT crowd stuff, HTTPS certificate generation and installation, certification authority, firewalls, ports, permissions, those sorts of things. So these are the non-NI tech aspects of this project. And with that in mind, we sort of came up with a list of things that what are you going to need to know if you wanted to replicate something like what we've done here. So assuming you already are a gun at LabVIEW or typical LabVIEW and you want to take it to this next level, what we're talking about here, then you're going to want to get familiar with LabVIEW NXG, and not just jumping straight into the web development, but also just actually getting familiar with the LabVIEW NXG environment and the experience before you get too carried away with web development. Getting familiar with the databases, not a critical thing to a web app, but really handy for what we were doing for our system. You're going to want to get familiar with the web services, like we mentioned before, understanding your HTTP requests and your methods. You want to get your head around toolkits, some of the toolkits we use. So the JKA, HTTP client, Dr. James Powell's SQLite library was really handy. Understanding the web developer tools available within your browser, whether it be Chrome or Firefox or things like that, understanding what you can do inside that. The NI package manager is used to deploy your NXG application. So it's important to learn about how that works, deploying your application as a package or as a distribution. you're going to want to get familiar with the NI web server and the NI application web server, different things, where you host your web app or your web services. And like we were saying before, there's a bunch of IT security certificates, permissions, firewalls. So this is what we had to work out. This is what we had to learn in order to deliver on this project we're about to tell you about. Any questions at this point, Stuart?
Answering a couple chat, nothing direct.
All right, cool. So, what I'm going to do now, I'm going to give you a quick background into the context of what we're talking about. So I'm going to give you an overview of the project that we did, so that when Stuart talks about his challenges and gives you his tips, you'll have some context. So we delivered a project this year to one of our clients. Our client, for a bit of context, they provide a quality certification testing service to meet international standards. So they do this for their clients. They, in their factory, have a number of different data logging systems to be able to perform this certification testing. And that all works fine, but what they needed us to do was to provide an interface for their clients to view the testing in real time, especially during COVID times in the pandemic. This has been invaluable. So their clients can now log in to our client's network and see tests being performed in real time, which is really valuable. So that was our objective, and here is our solution. So what do we got here? This is our block diagram. First up, what we've got is a number of different data logging systems down here in the bottom left. This was an existing system they already had. It has LabVIEW running on it, and it's just acquiring data from high channel count systems, acquiring a bunch of data, doing some analysis online, and saving that all off the file for further analysis later. Now, we took that LabVIEW software, we updated it to basically publish some data. So these systems got put on a network, and we used DQMH at White-In. So we created a DQMH module to produce HTTP posts and publish this data that these loggers were catching out to the network, to the internal network. So the data logging systems is publishing HTTP posts. So then what we did, this is where this project really kicks in, is we built a computer, just a standard Windows computer. We call it the local server. And on here, we're running a number of things. We're running a web services application. And this web services application, right, this is the glue to this whole system. It's the interface, like I said before. So it takes the HTTP posts from our data logging system and takes that data, it processes that data, turns it into a different format so that it makes it easier for the browser later, logs that to our database to keep the data there for viewing at any other time later, and also provides the access to the browser up in this other PC, which we'll talk about in a minute. Now, beside that, we also have the NI web server installed on this local server, right? So this is our web application. We wrote a LabVIEW NXG web application and deployed it here on the web server. It gets deployed as HTML, JavaScript, and CSS code, and it's running on this local server. And that's our browser, that's our web app. Sitting above that, so just before I go to the user PC, so these two bottom sections here, the data logging and the local server, that's all on an internal network. Now, at this point, anyone in the factory on the internal network can pull up a web page on their desktop computer in their office and log in to the NI web server on the local server here and see what's happening. They can log in and they can see the data. But our client wanted to make this publicly available, or privately available, I should say, to some of their clients, to select clients. So what we were able to do is we set up another computer. Actually, this is all done by our client IT's department, but they set up a user PC where a browser session can be run. And this is where we pull in some cameras. So we've got the data logging system, but also in the factory, they've got a bunch of webcams. And we were able to pull the camera code into the browser session running here on the user PC. And so the final piece in the puzzle is giving the remote client access. They chose a kind of quirky way to do this by just basically simply setting up a Microsoft Teams meeting, giving the remote client access via a Teams meeting, and then giving them control to open up the browser session and see their test data. And it's all controlled through the Teams meeting. So when our client decides that their client had their time, they can just stop having the Teams meeting. So our client's IT department preferred that approach. So that is our system.
Chris,
and
just to emphasize that point there, there's probably other solutions. In fact, there are other solutions to this sort of application, such as publishing measurement data to the cloud, say via System Link Cloud or things like that. This is the solution that we specifically provided, which was more around the local IT policies, and also the fact that the cameras needed to be integrated as part of that web app. So there's a lot of different technologies and possibly solutions that you could apply to a similar situation. This is just the one that we found most appropriate for this project.
Yeah, and their IT department was fairly comfortable just using the security of Microsoft Teams. So that's our system, right? So that's our background. So how did we get there? This is where I get, I punch it over Stuart. Actually, before I do that, sorry, I'm going to quickly show you what does that look like. This is what the remote client sees. So when they get their Teams meeting set up and they open up the browser, they'll get faced with a login screen, and so our client supplies them with a login, some credentials. They enter their username and password, punch that in, and boom, this is what they see. They can see the test data captured in real time. It gives them the instantaneous capability to see whether their test is meeting spec or not, as well as a bunch of other details. And if they click on a cameras button over here on this web page, it opens up a different tab, and they can get a snapshot into the factory as the test is being conducted. So it's pretty cool. They can get a full visual on what's happening, both at the data and at the physical. So now that I've given you a bit of context, I'm going to hand this over to Stuart, and he's going to dig into the details of how we did all that. But before I do, is there any questions in the chat there, Stuart, that we should answer?
No one's put anything in chat.
Okay.
Not yet.
All right. All right, well, I'll pass it over to you. I'm going to stop sharing my screen, and we're handing it over to Stuart.
Okay. All right, so we can see my screen now, can we?
I can see it, yeah.
Okay, excellent. Let me just get my notes up. All right. Okay, so thanks though, Chris. So now that Chris has given you an overview of the project, what I want to do is take you through some of the challenges that I faced as part of the development of that project. And from that, I'd like to present to you a set of 7 tips that I hope other developers can take away for their own projects. And honestly, I probably could have included 20 or 30 tips, but I managed to get it down to 7. And I know you're all itching to see this in action. screenshots are nice, but I can actually show you some real code, and I've got some of that to demonstrate. Now, I'm going to give you my first tip before I even begin talking about web applications, and that is learn LabVIEW NXG first. I imagine there's a few people watching this presentation thinking web applications, that sounds like something I want to do, but I haven't done it before. And that's fantastic. I encourage you to do so, but you'll be developing in LabVIEW NXG, which is a very different development environment, common LabVIEW. And if you haven't used it before, you want to get familiar with the NXG environment before you start on the web apps. You'll be wanting to get your head around different terminology like type defs are G types in NXG, packages and distributions, system designer, unplaced items, properties, local variables and how they work. And there are changes to the block diagram, like how functions are represented on the screen. And you learn to use cluster properties instead of bundle and unbundle. And you've got to relearn how to resize arrays. So there's a bit there to get your head around. Having said that, web app projects use a subset of the controls and indicators and functions available in the full NXG environment. For example, you can't have in-place element structures or timed loops or feedback nodes. And for some reason, you can have round and square LEDs in full NXG, but only square in LEDs and web apps. You can't have round ones, and I've got no idea why. So if you haven't used LabVIEW NXG before, I'd recommend you spend some time learning it. NI has some courses available, but I'd certainly be looking at NI's YouTube channel as well. And of course, you can test yourself out with the badges. Any questions about NXG or the environment? I'm not going to go too far into the LabVIEW NXG environment. That's for a different forum. But
no questions, Stuart. I just mentioned, though, if you jump over to the polls, I've asked a simple question is, I want to try and gauge how many people have actually had a go at creating a LabVIEW NXG web app. So when you get a moment, please answer the poll. Thank you. Back to you.
Yep. Okay, so moving on to the actual development. If you remember the system architecture that Chris showed you before on a previous slide, we had 3 software deployments: the data logger executable, the web services, and the web application itself. And they had to communicate with each other through HTTP requests. The data logger software would send measurements and statuses to the web services, and that's once every second. And that would write them to the database, and web application would request those measurements and statuses. Now, the general approach I took was I did all the coding for my messaging in the data logger software first, and then did all of the coding for my messaging in the web services, and did the tables for the database, and then all the coding for the messaging in the web app. The problem was when I got to testing out the functionality of the web app, I found that I needed to make changes to content of these messages, or define new messages, or whatever. And I had to go back and I had to update each one of the deployments just to make a single change. If you needed to make a change in one, it requires that you make the change to all. So my second tip is to simulate all of the messaging in a single LabVIEW application first, before you start developing multiple applications. That way, if a change needs to be made, the change is very simple. Now, as you can see in this diagram, I have a box on the left representing the web server, whether that's the web services or the data logger software itself, where I flatten the data that I want to send to the web app to JSON format. And then in the box on the right, I unflatten it again and do whatever I need to do with the data. Now, you will, in effect, be developing a lot of your web app in this simulation before you even begin your web app development. And you'll need to redevelop it in NXG after. But the overall development and integration time and risk, it can be reduced by doing it this way. I'll move on to the next challenge that I faced, and that was handling the data processing. And what I had in my original design was that I was writing data to my database in one format. But then after I queried those measurements in the web app, I had to reformat that data in the web app to display it. And that added overhead and it just slowed the process down. In fact, if someone came in late to the test, say an hour late, the web app would have to query an hour's worth of historical measurements. That's 3,600 records from potentially 200 channels, and reprocess every one of them for display. And it would take nearly 3 minutes for anything to be displayed after the client logs in. If it was 4 hours into the test, it would take 11 minutes. And the client's just sitting there looking at a little busy animation, wondering what's going on. So to fix it, I did the same reformatting, but externally. I moved it to web services after it had queried the data from the database, but before it sent the response message to the web app. And that cut the time down from nearly 3 minutes down to 3 seconds, because the data was already in the format that the web app needed to pass it to the graphs. And that's tip number 3. Don't make the web app do the hard work. Remember that the web app will be running in a web browser, which is not made for intense number crunching or over-architected applications. So I've just been talking about external data processing, but also you don't want to be resizing your arrays in the web app because you'll be continually reallocating memory. Instead, initialize a fixed size array and replace the elements as you need. Don't over-architect your web app. Simple architectures like a queued message handler, they're fine. Also, try to consolidate your messaging, not so much to reduce the messaging itself, but to reduce the number of events and conditions in the web app. Anyone have any questions so far?
No questions. I was just going to say it's the temptation is there to make the web app do more than it really should, isn't it?
Absolutely.
Because you're working in NXG, it's harder to realize if you're in the web development environment versus just your standard LabVIEW development environment. So you got to remember, hey, I'm actually in a web app right now. Don't overcomplicate it.
Yeah, you have to have a similar mindset to if you're developing, say, an FPGA, something like that. The development environment looks very similar, but you really got to keep in mind what it is you're actually developing for, what the deployment platform actually is. In this instance, you're actually developing a web application that's going to be compiled into HTML code and CSS and JavaScript. And as you say, the temptation is there to treat it like a normal LabVIEW application or a LabVIEW NXG application in this case. But there's some things that you just really got to be mindful of when it comes to actually deploying this thing.
Yeah, and just in the chat, Stuart, Aaron Gelfand, I hope I've pronounced your name correctly, Aaron. He's saying make the web app as simple as possible since it doesn't have built-in debugging right now. So there's a good tip too. That's
right. We'll actually get to a little bit of debugging in a bit.
Yep.
Yes, there is no inbuilt debugging.
Cool.
All right, so here's an interesting one. Excuse me. I use Firefox a lot of the time, mostly because it's not Google, and I don't want Google to see some of the websites that I visit. But during my development, I had some graphs that just suddenly disappeared. They just weren't being displayed. And I was pulling my hair out for hours, trying to figure out what I'd done wrong. And I just couldn't figure it out. And after a while, I thought, look, I'll give Chrome a shot, see if it's any different. And all of a sudden, my graphs reappeared. And so as it turns out, there was actually an issue with a recent Firefox update. So, well, I guess the Mozilla developers really need to start working with NI a little bit more closely to make sure that the functionality gets retained between releases. But the point is, your code might work for you in your chosen browser, but just make sure that it will work for your client, because they might be using a different browser. Also, if something goes wrong, just do a sanity check using a different browser, because it might not actually be your fault. So that's tip number 4. Test your web app out on different browsers. Make sure that your web app looks and functions the same. You may want to be retesting whenever there's a new release of those browsers too, for exactly that reason I just mentioned. And just on a related note, I also tried my web app on browsers on my phone as well, which was more out of curiosity than anything. But out of 6 browsers, I only had one that displayed the web app the way I expected it to. Maybe just something to keep in mind. Don't take it for granted that it's that your web app's going to be portable to a mobile device. Okay, next challenge. Sorry, was there anything on browsers at this point?
No questions.
Okay. All right, next challenge. Those webcams. As Chris mentioned before, there were multiple webcams that were set up around the facility, and the client, what they needed was to be able to select individual cameras and configure them for display essentially in real time in my web app. So how did I do that? Well, I had 2 options. The more attractive one, because it would have produced a better picture, was to integrate streaming video. And that's done using RTSP, which is real-time streaming protocol. And this would have been great, except that to integrate RTSP into a LabVIEW web application proved anything but easy, since it's not natively supported. We looked at integrating ActiveX DLLs and using third-party restreaming services and applications, and in the end, it was just getting too complicated and taking up too much time. So we looked at a simpler solution, which was to use image snapshots, and we would refresh those snapshots as often as we could. I should note too that there was an official API available for these particular cameras, but that was used more for configuration and status information. So that's great. We want to use image snapshots from the webcam, but how do we do that? Well, the webcams have their own web interface that can view exactly that. Well, these webcams did anyway. And what I did was to use the web developer tools in the browser to view the individual HTTP request messages. Now, sorry, that may be a little bit small to read, but I could click on an individual message and see what the HTTP request was to get that image, and also the response. So by doing this, I was in effect cheating by using someone else's design and reverse engineering it to be able to integrate it into the web app, into the NXG web app. So here's tip number 5. Use your browser's web development tools. For those who don't know, you can access the web developer tools by pressing Control-Shift-I, and that's common between Chrome, Firefox, and Edge. You'd primarily use it to verify and debug your web app, since you can check your HTTP requests, the response status codes and error messages. But you can also use it to see how other web pages are designed. And maybe there's something there that you can integrate into your own web app.
Stuart, you had to really flex your reverse engineering muscles on that part of it.
All right, next challenge. We know how to get the images from the cameras, but how do we display them in the web app? Well, I'm going to demonstrate that to you using a placeholder HTML container in just a minute in my demonstration code. And yep, that's what it looks like when you place it on the front panel. It's very non-exciting. It leads me into tip number 6. Add dynamic functionality with the placeholder HTML container. Now, remember what we're doing here. We're not creating a LabVIEW application, we're creating a web app. And when we put a placeholder HTML container on the front panel, we're creating an HTML element in our web app. And this element, we programmatically set the properties of, properties like inner HTML, which I can use to set the content of that container. We do that using Reflect, which is a standard built-in JavaScript object. So this is the sort of thing that's probably better demonstrated than presented. So I'll switch over to my demonstration program, which is on the wrong screen. Right, so here's our demonstration. Now I've put together a sample web application project, and we'll make this publicly available, hopefully in the next few days. So you can download it and play with it and plagiarize it. But it consists of a set of web VIs, which are over here on the left. And they've all been set to top level, which means they'll each be compiled into their own web pages, with this one being the start page. Now, I'm not going to go too in depth into the NXG environment or project structure or specific functions or anything, because we'll be here forever. But excuse me, if we have a look at the block diagram for this first page, it just consists of a simple event handler. And on button presses, we've got 3 buttons. On those button presses, we have an event defined for each, and it just calls a JavaScript function to redirect the browser to another page, whether it be one or the other or the other. So before I demonstrate, I'll just quickly show you how we're using the placeholder HTML containers, what the procedure is. Now I'll create a new web VI. If we go to the decorations menu, I don't know why it's in decorations, but that's where it is. That's our HTML container. If we right click on that, we create a reference. Put that on the block diagram. What do we want? User interface, panel manipulation, HTML container, obtain JavaScript reference. We wire the reference to the container to that function, and what we're going to be using, we're going to be using the JavaScript reference output terminal, not the reference to the object itself. Now we've also created a JavaScript library interface that we'll use too, which is the Reflect one. Go
Sorry,
to,
Stuart.
yeah.
You zoom in a little bit. It's hard to see on this screen.
Yep. Sorry.
There we go.
Okay. That's a good thing about LabVIEW NXG. You can actually zoom in. All right, so if we go to project items, software, application, reflect, property set. This is something that we've created earlier. We wired that up to property set, and that's referencing a JSLI file that calls, can't zoom in on this one, that calls the set method of the JavaScript reflect object. And using that allows us to set the values of a particular property. For example, string, that's the property name that we want to set. And that's the value that we want to set that property to. That's it. That's essentially all we're doing. So if we go back to the main application here, we'll be able to see that in action. Let's run that in a browser. So it compiles the web application. And we're now viewing this running in Chrome. Sorry, this is Firefox actually, but in our web browser. And one of the good things about this is you can zoom in and out, make it look neat. And just on a side note too, I've put in SVG graphics in here as well for the banners and the logos and things as well. And that allows us to retain our definition of our images as we zoom in and out. Okay, so I'm going to call the element page, which is this one here. It looks very unexciting, but if we go back to the code for that, you can see we're only doing what we just created a second ago, where we're setting the value of a particular property. I'm just doing that based on a value change event for the property value indicator on the front panel. Just give me a second. Now, so what we're going to do, we've got this web application running. I'm going to specify a property name. I've only ever used inner HTML, but there's plenty of other properties out there. I'm not sure how many of them are going to be useful. But let's set the value of that property to hello world. And we can see that the HTML element has been updated. The value of the inner HTML property of the HTML container has now been set to hello world. Now that's nice, but honestly, I could have done that using a string indicator or something like that. So let's tart it up a bit, and instead put a series of demonstrations here that I'm just going to copy and paste. Let's add in a little bit of CSS. So instead of just hello world, let's set the color to blue. Let's increase the font size, and we'll give it a nice blue box to set it in, like so. Excuse me. And the CSS is, there's a lot of CSS properties that you can use. I honestly haven't used them beyond essentially what's on screen at the moment, but with CSS, you can produce drop-down menus and the like in other web applications. I don't know if it will work in LabVIEW NXG. Maybe that's a homework exercise for people or even ourselves. Other things we can do. Let's put in a hyperlink. And that opens up a new link in your web browser. We can put in an iframe. And there's some familiar looking faces. Note here that I'm specifying other properties such as the height and the width. If you're familiar with web development at all, you may be able to set the properties in a bit more detail than what I can. We can put in an image. That one's for you, Chris. Or we can put in inputs. Now this is an input of type button, and all I've done is I've just set the value to click me. Now that doesn't do anything, but it allows you to add in that that functionality of creating an input type that your browser will generate for you. Now, how about we add in a little bit of JavaScript to make it functional. I've still got my button, my input button here. I've created a new paragraph, which is empty, but I've given it the ID of demo. But when we press the button, when we click on the input, what we're doing is we're setting the inner HTML of the demo element that we've just defined to the current date. So let's see what happens now when we press the click me button. There's today's date, or at least that's what it is here in Melbourne. Continue clicking click me, and that date gets updated.
Stuart, just a quick time check, mate. It's 12:50.
Is it? Okay. All right. Well, I'll quickly fly through some of these. So that's a good demonstration. How does that apply to the project that we used? I used those HTML containers to display the web app. The images from the webcams within my web app, and that's something similar to what I've done here. All I've done again is I've just set the inner HTML. Here's a publicly available webcam that provides images on the internet. And all I'm doing is I'm just querying that every 5 seconds and just displaying the results in this container.
Yeah, no one's at the beach because everyone's clearly in here in our GLA Summit session.
Yeah, well, those people on the beach there, I reckon, are looking at it on their mobile device, and hopefully it's coming out all right. So I can set properties such as, well, because we're down under, let's set the camera rotation to 180 degrees. And what that's done, there we go. We've set the rotate transform, which is a CSS property, to 180 degrees. I'll just change that back to 0.
We actually had to do this for our project because one of the cameras was rotated 90 degrees, right?
That's right.
Yeah.
And let's see what's happening in Japan today. All we're doing is just changing the source. And yep, looks like it's a busy day in Japan today. And yeah, we're just refreshing, we're just acquiring those images every 5 seconds in this case and displaying them on screen. Now, everyone can see the big problem with this method as it is at the moment. Every time we obtain a new image, it takes time for the web browser to refresh that image on the screen. And that's a problem that I had on site as well with the web cameras. It would take a lot less time, but it was noticeable. There was that flickering essentially between each and every frame. So what I had to do was, if we have a look in the next demonstration, now unfortunately this is determined to make a liar out of me by performing in exactly the same way as the previous demonstration. But you kind of have to trust me that it did actually work on site. I'm putting this down to network congestion or something other than my coding. But what I had to do was define this sort of coding, which incorporates some JavaScript on top of the image acquisition, the image snapshots. What you see on screen is actually two HTML containers, one overlaid on top of the other. And for each image snapshot that I'm querying from the web cameras, I load that image snapshot into one container and then into the other container, and alternatively one or the other or the other or the other. And each time one container has an image loaded, I show that one and hide the other one. So for each successive image, you show one and show the other, then you show the first one and show the other. And in that way, it becomes more of a seamless transition between each successive image, and it, in effect, provides a simulated live video feed. Now, as I say, this demonstration isn't working particularly well for that, but
on our client site worked well.
Yeah, but on the client site, this worked really quite nicely, and that refresh interval I was able to get down to, say, 4 or 5 frames per second, and that was a pretty good approximation of a live video feed. So that is the webcam, the web application demonstration.
Make it sound so simple, Stuart, but it took a fair time to get to that, didn't it?
It did. So look, I'll just quickly wrap this up due to time. I do have a 7th tip. Don't be afraid to use IT support to assist with your setup. We, as LabVIEW developers, we may not be able to provide the complete solution when it comes to deploying a web application. There's a good chance that your client's IT security policy will require you to implement SSL encryption and authentication and SSL digital certificates, and they can only be issued by certification authorities, by mere LabVIEW developers such as ourselves. Depending on the client and their IT policies, you may need to talk to your client's IT people about firewalls or ports or permissions, etc. Right, so that wraps up the main part of the presentation. Before we get into questions, we'd just like to acknowledge Matthias of StudioBods. It was his presentation at NI Week last year that provided us with the inspiration to start learning and developing web applications. And I'd recommend that you check his presentation out. It's still available for viewing. And he has a sample NXG web application available to download as well. So that's it. We'll open it up to questions.
Yeah, I think we can jump over into the breakout room now. So if anyone has any further questions, feel free to jump over and join us there in the breakout room. But yeah, thanks, Stuart, for presenting this with me today. And I hope that we were able to give some insight. There's obviously a lot left out in this presentation. We can only squeeze so much into 1 hour, but I'm happy to answer any questions about anything specific in the breakout room.
Sorry, very quickly, just to answer Aaron's question there. Yeah, cause was an issue, but if you have a look at Matthias's demonstration and downloadable code, he does address that there, and I did integrate some of that into this particular web application.
Yeah, all right, well, we'll move across to the breakout room now. Thanks, everybody. Thanks for having us.